Hello, everyone, and welcome back to another Fusion 360 live stream. I'm your host for today, Jason Lichtman, and with me I have our friend Brad Tallis on the keyboard. He's going to be answering any questions that you have that you type into the chat window. So today we are going to be talking about one of my favorite topics. We're going to be talking about meshes and how to reverse engineer those meshes into Fusion 360. And you might wonder, why are meshes so frustrating? They are so frustrating sometimes, but we're going to answer that and a whole lot more in today's live stream. I expect today's live stream to last about an hour, plus or minus a couple of minutes, because we have a lot of really good stuff to cover. We're going to be using a couple of slides, but then mostly inside of Fusion 360, showing you the ins and outs of how you could actually take those meshes and reverse engineer them. So let's jump into the really good stuff. We're going to start off by asking ourselves a question, which is, what on earth are meshes, right? And I'm just going to warn you guys right now, I've gotten some feedback over time that I sometimes get a little bit too basic. And I have to start off basic because I want to make sure that everyone, whether it's the more advanced users or the more new users, all can actually learn from this live stream. So we're going to start off with a really big the basics of what meshes are, why they're hard to work with, and then we're going to get much more advanced really fast. So whether you're a beginner or you're more advanced, you're going to learn a lot from this presentation, or at least I very much hope so. So let's go and jump over to my slideshow, and here you're going to see that we're starting with what is a mesh. A mesh is a way that you could represent a 3D object. And for the record, it's one of many different ways that you could use to represent 3D objects. We'll talk about what some of the other ways are and what the differences are between them in just a minute, but we're actually going to go even more basic than that. We're going to start off with 2D. So what are the different ways you can represent a 2D model? And basically, there are two different kinds of ways you could represent them. You could represent them as rasters or bitmaps. They're the same thing. Or you could represent them as vectors. And on the screen right now, you could see that I have our Autodesk logo, or it's actually the word mark, Autodesk. And on the left, we have the raster, the bitmap, and on the right, we have the vector. And they look exactly the same. The difference is going to be when you start to dive in a little deeper. So let's actually zoom in a little bit. And you could see that when we zoom in on the A on the left-hand side gets a little bit more blurry when I start to zoom in. The one on the right-hand side, the vector, stays nice and crisp. But what happens when we start to zoom in a little bit further? You're going to see that the one on the left gets a lot blurrier, and the one on the right stays nice and crisp. The reason is because rasters or bitmaps are actually made up of lots of little dots or pixels. When you buy a new phone and they talk about how many megapixels it is or how many pixels per inch it has, that's what it's really talking about. How many of those dots do you have in your surface area of your screen? When we talk about vectors, it's a little different because vectors, instead of defining the shape based on lots of little dots, it defines the shape based on the math behind the shape itself. And as a result, you can actually scale those vectors up or down and never lose any of the crispness. So if you think about taking a picture on your iPhone or an Android phone and trying to print it at like an 8.5 by 11, you're going to get a good picture no matter what. But if you end up going and try to make a billboard out of your iPhone picture, or even just a really big canvas for your house, you're going to find that the image gets very blurry very fast. And it's because the dots, you don't really want to scale the dots themselves, and so it ends up getting blurry. That's like the short version of it. So let's talk about how this applies to 3D. So let's talk about how you can define a 3D shape using different methods. So the following are going to be different ways you can represent a 3D model. This is called wireframe, and this is very common in things like AutoCAD or some other older CAD programs. This is basically defining the frame or like the outer shape of the part. And those are wires. And then everything else in between is really a connection of those wires. This is called a boundary representational surface or solid. We call those BREPs for short. And BREPs are kind of more common these days. Fusion defines everything as a BREP. Inventor defines everything as a BREP. Creo, which used to be Pro Engineer, does the same, and even SolidWorks. So this is kind of more of the standard these days. But there are other ways you could define 3D models as well, like point clouds, which happen to mostly come from 3D scans. These are basically points in space, and if you were to look at enough of them, it looks like you're looking at a full solid object, but really you're just looking at a point cloud, or rather a cloud of lots of little points. You could also look at an object as sub-D surfaces. That's just a short version of subdivisional surfaces. That's kind of like the T-spline technology that's built into Fusion in the form or the sculpt environment. And then you have other ways as well, like meshes. So as I said earlier, meshes are really just a way that you could define a 3D object. And the way it does it is that it takes 3 points and it connects them together in triangles, or at least mostly in triangles, and you end up with a lot of these triangles. Sometimes it's a few thousand, sometimes it's multiple hundreds of thousands, and sometimes it's in the millions of triangles. Now, what you might not know about meshes is that triangles are not the only way to connect all those dots. You could actually also connect those dots using quads. And when we have a mesh made of quads, we call those quad meshes. And here you could see another mesh, this time made of quads, instead of, if we go back for a moment, triangles. So same object made of quads versus triangles. So you have a bunch of different ways to define 3D objects. So the question is, why is working with those meshes so challenging? What it comes down to is that every program has a specific way that it likes to model. And Fusion 360, like SolidWorks and Inventor and some other softwares out there, are mostly using BREPs, or that boundary representational method of defining the geometry. The cool thing about Fusion 360 in particular is that it's called Fusion because it's a fusion of multiple different ways to model. So in addition to having solid modeling and surface modeling, both which use BREP as the way it defines geometry, we also have the form or the sculpt environment, which uses sub-D to be able to define the geometry. And when you exit out of there, it actually converts it back into the BREP surface so that it's easier for you to work in that BREP environment. But we also have the ability to bring meshes in as well. But we're primarily a BREP modeler, which is why working with meshes can be a little bit challenging. You do have other softwares out there, and you've heard of them, things like ZBrush or Freeform. There are a lot of tools out there, or Mesh Mixer on the Autodesk side of things as well, and Mudbox, that all primarily work with meshes. And as a result, they have a lot more mesh editing tools than Fusion, which is primarily that BREP modeler, but has mesh tools also. That's really why working with meshes from an engineer's perspective can be difficult, because most engineering tools, like the ones I mentioned earlier, those are primarily BREP, or that boundary representational method of working with files. So that's why working with meshes is difficult. But know that Fusion can actually handle meshes much better than any other BREP or boundary representational tool that I've seen. It's incredible. I love working with meshes in Fusion. And so let's talk a little bit about, oh, and this is, by the way, all of those different ways to represent 3D models all on one slide. Let's talk a little bit about how to access those tools in Fusion and what you could actually do in Fusion. And then we'll talk about the ways you can actually use them. So the tools, first of all, to get to them, right now Mesh is a preview. So go to your preview, make sure to turn that off. Sorry, turn it on. Otherwise you can't use it, of course. So turn on the Mesh workspace, and then you're going to want to bring in a mesh into Fusion. There are 2 ways you could bring meshes into Fusion. You can upload the mesh into Fusion directly, and you could use the insert mesh option. I recommend to use the insert mesh option over the upload. And the reason is because meshes, generally speaking, are unitless. So if you have a box and that box happens to be 1 by 1 by 1, it doesn't know as a mesh if that's 1 by 1 by 1 inch or 1 by 1 by 1 millimeter or feet or miles. It just has no idea. So when you upload your mesh via the upload tool, it actually assumes, and we all know what happens when you assume. Our parents taught us that. When you assume, you get it wrong more often than you get it right. Our default units inside of Fusion for importing is going to be centimeters. Most people actually work with millimeter, or they work in inches. So when you upload, it's going to come in centimeters, and then you're going to have to scale that to the right size. If you use the insert mesh option, you're going to get additional options there. And that's going to ask you what units that file that you're bringing in was created in. And you could choose, I made this in inches, import it in inches, or I created this in millimeter and import that in millimeter. And it'll come into the right scale right away. So that's kind of the basics. So once you bring a mesh into Fusion, these are going to be the tools that you have access to. Right now you can see I'm in the mesh tab inside of the design workspace. That's where you're going to find the mesh tools. And if we look at those tools in a little bit more detail, you could see that I have the following. I could remesh my mesh. I could reduce the number of triangles in that mesh. They're very similar, remesh and reduce. A little different, but very similar. You can close a mesh that happens to be open. You can also erase a section of the mesh and fill it in, which is going to fill it in tangent to the area around it that you did not delete. You can smooth out an area if you have a bump that shouldn't be there. You could also cut the mesh using a plane, typically a construction plane that you'd create. You could reverse the normals, which is like inverting the mesh inside out. You can delete faces of a mesh. You can separate a mesh, which is splitting it into multiple meshes, and you can merge different meshes together as well. You also can move or copy the mesh, like make multiple copies or reorient the mesh into new positions. And then lastly, you can scale the mesh to different sizes, which is very commonly used if you uploaded your mesh in a centimeter. So those are generally speaking, those are the mesh tools we have inside of Fusion. But there are a lot of ways you could actually use these in kind of more interesting methods. And the goal here is going to be reverse engineering. I should also note that today happens to be September 26, 2019, and everything that I'm showing you is going to be accurate as of today. We are actively working on improving our software, pretty much always, but the mesh workspace is one that we're working on, and so you might see updates coming up soon that have different mesh tools or more mesh capabilities than before. This was discussed actually at Fusion 360 Academy about a month and a half ago in Portland, and if you want to look up a little bit more about what was discussed, we are uploading that to our website. It was a presentation by Daniel Graham, and it was fantastic. But everything I'm showing you today is accurate as of today. So let's jump into Fusion, and I'm going to show you 5 ways to reverse and hold on. Let me skip all of these slides. We're going to show you 5 ways to reverse engineer your mesh files. And I'm going to give you a quick list so that you can follow along with all 5 different ways that we're going to show you today. We're going to start off with using the mesh data as is, which is an interesting one. It's kind of the reverse of what you might have thought we're going to do today. But the other 4 are definitely going to be exactly what you might have expected. We're going to convert meshes to B-reps in option number 2. We're going to convert the meshes to B-reps using an intermediary. We're going to go from a tri-mesh to a quad mesh to a T-spline and then to a B-rep. Sounds a little bit long-winded, but it's easier than you think. We're also going to go and pull sketch cross sections, and then lastly, we're going to use T-splines to pull a T-spline to match a mesh as well. So let's jump into Fusion 360, and I'm going to show you all of these workflows. Here you could see a beautiful off-road motorcycle. We are calling this the Trail 450, designed by Israel Del Toro in our tech marketing department. Great job, Israel. And this particular file has quite a few meshes in it that we're going to look at. And so let's go and look at one of them in particular. We're going to zoom in on the front wheel, and you could see here that the front wheel hub, that's the object I just selected, and now it's blue, and now it's orange. You can see that there. This is a mesh file that we could go and look at, but the crux, or not the crux rather, the key for reverse engineering method number 1 is you don't always have to reverse engineer everything. In fact, if you reverse engineer it, you're adding work for yourself to do. You know, that's steps, that's time, that's areas for you to maybe make mistakes you don't need to make. But overall, it's going to be time that you're spending reverse engineering it. And the question you should ask yourself is, do you really need to reverse engineer that object? Can you actually use this object as is in its current state, which is an object that you can go and put into position and use as an underlay? If you're not familiar with an underlay, I want you to think about if you were to trace an image. So you print out an image on a piece of paper, you take a blank piece of paper and put it on top, And you could easily, press those two pieces of paper together, maybe even have light in the background so you could see it easily, and then you'd trace on top. It's a great way for you to design and a great way for you to be able to replicate something that already exists. And so in this case, if I have a front wheel hub and I'm trying to design something like this mounting piece right here for this disc brake, I could actually design this without reverse engineering the mesh at all. I could just design this piece and use the mesh in the background and design to match that piece. I don't actually need to have vectors or anything else to be able to work with. So all I could do is just leave it in here and use it. And now I'm actually thinking to myself, and this is kind of the fun part about live streams, is live streams aren't perfect. And so what I didn't explain earlier that I meant to explain is why I talked about the difference on 2D between the pixels and the vectors. I want to give you that analogy and make that make more sense in 3D as well. So in the analogy that I talked about earlier, we have pixels and you'd have separate programs to design images that are in pixels, right? So Photoshop is a pixel-based image editing program. So when you're drawing something, it's actually drawing a bunch of dots in whatever color you want. And then when you go to Illustrator, it's a vector design program. Those both, by the way, are owned by Adobe. That's Adobe Illustrator and Adobe Photoshop. But many of you might be using those programs, so this analogy will hold true for you. So Photoshop is pixel-based and Illustrator is more vector-based. They both end up having the same goal of making incredible images, but there are different techniques to use each one. That being said, there is also you have the capability in Photoshop to be able to bring in vectors from Illustrator just as easily as you could bring in bitmap images or raster images from Photoshop into Illustrator. But the techniques you use to work with those images are going to be based on what program you're using. The same thing is also going to be true in 3D. So if we make that analogy a little bit further, we're going to talk about the vectors are going to be very similar to the BREP or boundary representational solids that I talked about earlier. And the meshes are going to be very similar to the pixels. The difference is that the pixel, instead of it being just a little dot, I want you to think of those pixels as triangles. So each of those triangles in the mesh is like a pixel. And the vector is a little different, right? Because it's math-based. You have a little bit more control over scaling the vector or the BREP up or down to any size you want. It comes out perfect every time. But if you take a mesh and you scale it really, really big, you're going to find that each of those triangles is going to seem very faceted compared to the model. And now that you've heard this, maybe you haven't thought about it that way before. Maybe this makes a little bit more sense to you, right? Why dealing with meshes in a BREP environment can be a little bit more challenging because you're talking about working with pixels in a vector program. But remember, you can still bring in your meshes into Fusion, just like you could bring in your raster images, your bitmaps into Illustrator, even though it's not Photoshop. So I apologize for explaining that a little bit late. I meant to say that much earlier, but I hope you learned from that anyway. So again, in this particular instance where I'm showing you that first method of reverse engineering is just to not reverse engineer it, it's just use it as the background. So you could bring an image from Photoshop into Illustrator, and then you could draw your vectors on top of that bitmap image. The same thing is true here. I could bring in my mesh into Fusion, and I could draw my BREP adapter plate or to hold my disk on there. I could actually design that as a BREP while just using the mesh as like a background. So generally speaking, if you don't need to reverse engineer your mesh, do not reverse engineer it. It's a whole lot of work. It involves a whole lot of areas where you could have imperfections and things like that. Just leave it as is. This is a great example of that. The second workflow that we talked about was the mesh to BREP. And I'll tell you, it's limited in what it can handle. If you want to bring in a 1 million triangle mesh, you're not going to be able to convert that into a BREP in Fusion. But if you have something a little bit more reasonable, maybe it's something like 40,000 triangles, you can certainly do that. So let's go and bring in another example. Here I have, as part of my motorcycle, I have a brake lever on the right-hand side. We're going to go and find this in the browser. I'm going to go and open this file separate from everything else. And let's go and look at what I have inside here. I have a bunch of triangles. Let's go and figure out how many I have in here. I open the bodies folder. I can right click and go to properties. And it turns out we have 15,000 or so triangles in this mesh. This is a pretty small mesh. If I had a scan, this was actually created from a BREP model. I'll just be very direct with you on that. And that's why I have only 15,000 triangles. If I had scan data, this might be closer to 50,000. Depending on the resolution of that scanner, this could be a million or 5 million triangles. This could be a lot. In this case, what I'm looking for is less than 50,000 triangles. In particular, 49,999. That's what my goal is, less than that. If I have more triangles than that, remember, you could still use the mesh tools to reduce your mesh count. So all I have to do is actually go into my history here. I can see I have a mesh feature, right click it and say edit. And then at that point, I get all of those mesh tools that we talked about earlier. I can select a region of my mesh if I wanted to reduce the mesh count, go under modify and say reduce. And I could choose here, 0.25 means 25%. So this is going to take however many triangles I just selected and try to turn it into 1/4 or 25% of that number. So reduce it to 1/4. And this could help me if I have 100,000 triangles. Maybe I reduce my mesh count by a factor of 0.5 or 50% until I get just under that 50,000 mark. So let's say I've done that already. And now I have my mesh. It's at 15,000 triangles. Let's go and turn this into a BREP. Again, we're converting it from one way to define a mesh into another one way to define a 3D model. That's really what I meant. To another way to define a 3D model, one that gives us more powers in Fusion because Fusion primarily designs as BREPs. So I'm going to go in here and I right click and I don't see any option to convert this into a BREP. I'm also going to go under my modify menu and I don't see any option there either. Now, part of the reason that I'm not seeing any of those options is because right now I'm in the mesh workspace itself. So let's actually exit out of there. I'm going to say finish this mesh. And let's go and try that again. Right click on the mesh. And I do see the edit option, but I don't see anything about conversion. Let's go under modify, and I don't see that either. And there's a good reason for this. And the reason is because not only does Fusion work primarily with BREPs or those boundary representational objects that we talked about earlier, but it's also a parametric modeling tool, primarily. Parametric means that it keeps that history, that recipe card for how you design your model. We call that a timeline, and you can see the timeline down here at the bottom of my window. With this timeline on, I don't have the ability to turn this into a BREP because that conversion is not actually parametric. It's a one-time, non-parametric, non-editable feature. And as a result, I have to make sure that I don't have my parametric modeling on when I access it. So to get the parametric modeling off, all I'm going to do is right-click on the very top of this model here and say, do not capture the design history. We're going to give you a warning telling you that this is not exactly reversible, but you're going to say, I know that. Let's hit continue. Now you'll notice the timeline that was at the bottom is no longer there. So it's gone. I no longer have parametric modeling on. So now let's go and right-click on our mesh again. Now you're going to see convert, and you're also going to see mesh to BREP, which is actually what I want. And if I go under modify, I'm also going to see this convert button, and I'm also going to see mesh, and under mesh, I'm going to see this mesh to BREP. So just know that when you turn the parametric modeling off, you are going to get more options than you would otherwise. And so what I'm going to do now is we're going to say, let's do this mesh to BREP, select the mesh, which I already had it selected, so it did that no problem. I'm going to say OK, and it's giving me this warning. This warning is going to show up if you have any number of triangles over 10,000, and it's going to warn you just that you have a very big mesh. And it's saying big is 10,000 triangles, right? So it's all relative. I know that you might have 1 million face count meshes. That's possible too. But for this type of conversion, 10,000 is considered large, and then 50,000 is the upper limit. You're not going to be able to do this over 50,000. If it gives you this warning, you say, I get it. I know that it's more than 10,000, but I also know that this is less than 50,000. Let's hit that OK button. And in the background, it's doing a conversion from one way to define the geometry to another. Now I have a BREP solid. You can actually tell that it's a solid because I have this gray cylinder icon as opposed to the mesh, which has this yellow icon with kind of like a mesh kind of thing going across it. So this also looks mostly the same as before. What it did was it converted each triangle that I had in the mesh to a triangle that's a BREP. And the reason that we said earlier that more than 10,000 is a lot is because every time you go to rotate this model, the software is actually calculating how each face is going to look. And right now I have just as many faces as I had triangles in my mesh. So I have 15,000 BREP surfaces that all happen to be triangle shaped, but that's a lot. And if this were 50,000, this would certainly slow down my computer a little bit more. And if this were a million, my computer would slow down to a crawl, right? That's why we don't allow you to go past 50,000. So here I have a BREP, and if all you care about is having a BREP and exporting this as an IGES or a STEP or something else, you've already won. You've succeeded. You're done, right? So this model is a solid. It's a BREP. You can save this as an IGES. You could save this as a STEP model. You can just go to File, Export, and choose whatever option you want there. But what I'd prefer to do is to try to simplify this model as much as possible. Now, there are a couple of techniques that I'm going to show you that I really like to being able to simplify this model. Some of them are simple and straightforward. Some of them are a little bit more elaborate, but I'm going to show you them anyway. We're going to start off by starting off simple. If you look over here at this face, this triangle, and this one here, oh, by the way, now that it's a BREP, I could actually select individual triangles, also edges, and also vertices, however much I want. That means that I can create sketches. Let's actually go and do that real quick. I can create a sketch and I could project geometry from other vertices that I already have here. So I'm hitting P for project, and I'm going to go and project a couple of these points on this face over here. And we'll go and grab maybe this one over there too. And I'm going to go and add an arc. Let's go and add a quick arc, a 3-point arc. I'll go and draw it about that big. Let's go and hide my solid for a moment, and I'm going to use my constraints, in this case the coincident constraint. We're going to constrain this arc, and now poof, it's black, which means fully defined, and it's in the right position. And what I could do if I want to is I could just extend this sketch to be a little bit bigger than my model. Perfect. We'll come back to this in just a few minutes. But now you saw that you could actually project geometry from here. And by the way, when I go back, I can actually go and create sketches. I could project the entire body too. Let's go and do that for a moment. So let's go and maybe we'll edit our sketch. And I'm going to go and project this entire body. We'll go and select this body here. But I should warn you that when you project a body like this, what you might end up with is what we call polylines. And polylines are like short line segments. So if you zoom in here, you could see that I have all of these individual lines because it's projecting each of those edges, and we have a lot of triangles. We have 15,000 triangles, so I have a lot of polylines. And this could be a headache to work with. So I'm actually going to undo that, but I want you to know that you can do that if you want. Okay? So now that we've undone that, we still have our original arc, but I'm going to show you a couple of ways you could simplify this model. This triangle and this one and this one and this one and a bunch of other ones are really one flat surface. If you look at, the angle between them, it should be 0 degrees or something really, really infinitely close to 0 degrees. And our software does have tolerances in there as well. So what I could do is I could select one of these triangles, and when I hit delete, it's going to try to take the other triangles that are nearby and extend them so that it fills in that empty area. But if it sees that a bunch of those triangles are actually like within tolerance of each other and pretty flat, it'll actually merge them all together. So I select a triangle and I hit the delete key on my keyboard, and kind of like magic, this is going to replace, I should select it and then hit delete, or it doesn't work, of course. And I'm going to select it, hit delete, and what it's going to do is it's going to actually take all of those, merge them together, and now I have a single flat face. That's pretty amazing, right? That means that I could also come in here and do the same thing over there, hit the delete key, and I'm going to get a simplified surface over there as well. We might be able to do that over here also. So it turns out I've been muted for quite a while. I just got a call from Brad. And Brad, can you tell everyone how long I've been muted for?
Yeah, you've been muted for a while.
How long, Brad?
Probably about 5 minutes at least.
All right. We are going to start over 5 minutes ago. So, fun stuff on live streams. I'm going to go back in time 5 minutes, and I think I know where we were. So we're going to start over from 5 minutes ago. Let's go back in time. And I don't know if you guys know this, but the undo command will go back as many times as you want. So we're going to go back quite a ways. Hopefully you guys have patience for me and find that this is going to be valuable. We're going to go back quite a ways, and I'm going to show you all of the reverse engineering in this B-Rep from scratch. So we're going to start over right over here. This is where we had our B-Rep with a triangle for every one of our faces. So we had 15,000 of them. And what I could do here is I could select an individual triangle like this or this one. And hitting the delete key, what it's going to do is it's automatically going to go and try to fill it in with all the surfaces that are around it. So just like that, it now goes and turns it into a single face. And the reason that it's able to replace all of those triangles is because it sees the tolerance between them. And it sees that they're close enough to flat that they're probably supposed to be flat, and it turns it into a flat face. So I could do that right over here. I could do that in this region as well. And I'm going to get a flat face there. I could do that over here too. And I'm going to get a flat face there as well. I could do that over here and end up with a flat face also. And I could do that as many times as I need to simplify my model. Pretty cool. We're going to go over here and we're going to do this again. You guys just didn't hear me before. And we're going to make a surface, and we're going to go and extrude this arc that I created earlier. And we're going to go and extrude this symmetric in both directions. And I'm extending this past the actual faces of my model. And then I'm going to go and use, under solid modeling, we're going to go and use the replace face command. And I'm going to choose some of these triangles. And I'm going to go and choose a whole bunch of them. We're going to replace all of this in one shot, make up for lost time earlier with my muted microphone. And let's select this one also. We're going to choose our target is going to be this big surface that I created. And it's automatically going to replace all of those triangles with our new surface. And so you could see that in a second, this is going to be nice and clean. This is the kind of surface that I want. And that looks really good. We're going to go over here and we're going to do the same thing over here, but this is going to be a little different even. We're going to create a sketch and we're going to project, just like we did earlier with our arcs, we're going to project a couple of points here. And I try to make these as far away from each other as possible so that my circle is going to end up being as accurate as possible. We're going to go and draw a quick circle. I'm going to go and use my coincident constraint between these points here. And we should have our circle in just a second. There we go. Perfect. Circle. Now I could use the replace face command if I want to, but I want to show you a different technique. So let's go and hide our sketch. We're going to go in here and I'm going to select everything that's inside this box, just like that. I missed a couple of faces, so let's go and select those as well. And I'm going to hit the delete key and we're automatically going to heal that up, patch it, right? That was easy because I already made this front surface and I already made the back surface flat. So I didn't have a million triangles to have to go and sort through there as well. But I also have my sketch here. And so now I could, if I want to, just extrude this through and I'm going to end up with a perfect cylinder. Now something is actually a little bit funny here. I think I know what the deal is. Let's go back and edit our sketch. And we're going to hide our solid model here. And I see I have to go and delete that guy right there. So what I have here is I have an option turned on that you could turn off in Fusion. Let me show you what that option is. So under Preferences, and we might have to go and find this a little bit. I think it's under Design. There it is, I think. Auto Project Geometry on Active Sketch Plane. What that did was it automatically projected all of the edges of that circle. And so when I go to do my extrude, it's trying to use all of those edges instead of this nice clean circle that I made. So I turn that option off usually. If you use it on, just be aware that that happens. You might want to delete that geometry in this case. And let's go and see what we do here. We're going to go and do our extrude and go through. And I still happen to have that geometry in there. But if I didn't, this would be a nice clean circle. So just be aware of that you could go and use this geometry to make your extrudes and everything else. Again, the point here is simply to reverse engineer your data. And in this case, we're working with BREP, so you're able to do that. So this was technique number 2, convert your model to a BREP. And again, you're limited to 50,000 triangles, but this is a great technique as long as you have models that are less than 50,000, or you could remesh your model. You could also go and split your mesh into multiple pieces that are each less than 50,000. You could then convert each one and merge them all together, but just be warned that the more BREP faces you have, the more processing it takes from your computer, and eventually that is going to slow you down and you're not going to be very happy. Okay, so next option on my list here is quad mesh to T-splines to BREP. And let's go and show you another example. We're going to jump over to my motorcycle. And here I have, near the same area, I have a foot peg. We're going to go and open this foot peg up. Let's go and find it in a browser here. We're going to go and open this foot peg. And let's see what we have in here. This one is just a regular mesh, only one mesh. I think I really just wanted the left foot peg. Let's go and check that one out. Let's go and check the left side. See this foot peg? Yeah, this is the file I wanted. And let's go and open this one up. So remember earlier how we talked about how most meshes happen to be made of triangles, but there actually is another type of mesh, and that type of mesh is a quad mesh, right? Made up of squares or quads. Well, let's go and take a look at what I have in here. I have my tri-mesh, which is made of 81,000 triangles. And then I also have a couple of other meshes in here. This one's a quad mesh of 20,000 triangles, 20,000 quads. I have one of 10,000 quads. I have one of 5,000 quads, and it's starting to look a little bit ugly, not accurate. And when I go to 2,500 quads, it's really not getting nice. But the 20,000 quad mesh, I think, is actually looking really good. And the first question you're probably asking is, how did I even get this? Well, I use an Autodesk software called Recap Photo. I'm going to go and pull that software up real quick. Recap Photo is a great program. It's mostly meant for photogrammetry. So you take a bunch of pictures with your camera of an object from all views. Like if I wanted to scan this water bottle and I don't have a 3D scanner, I could take like 50 pictures of this water bottle from all different angles, and then I could upload all of those images into Recap Photo, and it's going to use photogrammetry to figure out what the 3D model is. It is really cool stuff. One of the cool things about this software is, in addition to doing that, you can also create quad meshes. So if I want to mess with maybe the left foot peg, we're going to go and grab our left foot peg, just like this. And I could rotate it around and look at it. But all I care about in this software for my purposes today are going to be to export this. And I'm going to go to export the model. And you'll see that I can export this as an OBJ or an OBJ as quads. Now, one of the limitations of this software is that I can only go up to 20,000 quads. If you have a really high dense mesh, you might want to use a different software to be able to do this conversion. And I'm hoping in the near future we have this ability in Fusion as well. But we're going to see. In the meantime, I'm using this program. There are a variety of other programs you could use that'll do something similar. But the idea is you want a quad mesh. In this case, Recap Photo is going to give you a quad mesh. Once you have that quad mesh, you would insert it into Fusion just like you would any other mesh. And my recommendation is still insert mesh, choose your OBJ or your STL from your computer, and then choose your units to make sure it comes in the right size. Once it's in, now we're going to do some magic. This workflow is going to be the quad mesh to T-spline to BREP workflow. And for that, we do need T-splines. So I'm going to go and say create a form, which is jump into that T-spline or form or sculpt environment. We're going to click that, and now I'm in this sculpt or form or T-spline environment. We do have an option here under Modify, and you're going to see here, nope, it's not under Modify, I'm wrong. It's under Utilities. You're going to see Convert. So you go into Convert, and what you want here is actually quad mesh to T-splines. I select the quad mesh itself and hit OK. It's going to convert all of those quads into T-splines. And part of the way that this is, the reason it's able to do this with quads instead of the triangular mesh is that the math behind how we define the geometry for T-splines happens to be more like, square shape or quad based rather than triangles. And quads are also quad shaped or square shaped. And as a result, we're able to convert each of those quad faces, instead of into a B-rep, into a T-spline subdivided surface. So here I have my T-splines. It looks exactly the same as it did before, but the edges are now a little bit more bold, I would say, or a little bit more highlighted. Under the bodies folder here, I could see body number 2, which is a T-spline. And by the way, as a T-spline, it means that I can edit this if I want using the T-spline methodology. So if I want to go and say, let's edit this shape, I could go and select any of these vertices or edges. Let's go and select an edge or face or multiple, doesn't matter what you want to pick. And I can come in here and pull on this and create more organicness to this shape. I'm going to leave this bump in here, even though I know you probably don't want the bump in there. I just want you to see that you can actually edit your mesh right here. And I'll give you another example in a few minutes that'll be a little better for this kind of thing. But the key is that once you have your mesh, your T-spline rather, if you decide to edit it, great. But when you finish the sculpt or T-spline or form environment, what we're going to do is we're going to convert into that B-rep that we talked about earlier, the B-rep that we traditionally work with in Fusion. And as a B-rep, now you can save this out as a step model, as an IGIS, as a parasol, whatever it is you want to save this out as, no problem. And you're going to see here that the number of faces that I have here is a lot less than a one-to-one conversion of the quads. I started with 20,000 quads, and I don't have nearly as many faces as a B-rep. I actually have as few faces as our software calculated you needed to be able to make this into a solid. This looks a little bit ugly, and in some respects it is, but if all you care about is having a solid that you can import into other programs that don't play as nicely with meshes as Fusion does, like SolidWorks as an example. If you happen to be using SolidWorks on a regular basis, you probably don't bring meshes right into your SolidWorks environment for a variety of different reasons. If all you care about is using Fusion to create a solid IGIS or step that you could bring into SolidWorks or Inventor or Creo or anywhere else, this is a great way to do that. Convert your mesh into a quad mesh, or start off with a quad mesh depending on how you're making your mesh in the first place. Bring that into Fusion, convert that to your T-spline, convert that into B-rep, and now you have your solid. I could again save this as a step or any other generic or neutral file format that I want. And of course, I could go and use this in Fusion assemblies. I can also go and make changes to this because this is a B-rep now. So if I wanted to make some sort of cut in my model, I could go and turn on my origin and all my planes here. I could view this from above, and if all I care about is making a hole cutout, I could go and draw my hole, whatever size I happen to want. Maybe this is going to be 1/8 of an inch. Line this up however I want to line this up, and when I'm ready, I could just take this sketch and extrude through this just like it were any other B-rep model. And just like that, I have my cutout. So just keep in mind that this is a great workflow for you to use. Again, that's going to be quad mesh to T-spline to B-rep. This works even better for more organic shapes, especially if you want to go and make some changes to that organic shape. You could do that in the T-splines environment and you'll still get a B-rep. We have 2 methods left and about 10 minutes, so this will be interesting. But we have 2 more methods left, so let's go and show them. The next one is what I call pulling cross sections. And you saw earlier in the brake pedal that when I converted to a B-rep, I could make a sketch and I could project geometry. But the problem that I had there was that the sketch had those polylines, all of those little edges, and those little edges are going to be just as ugly as the mesh that you're starting with. So you might not want that. You might want a much cleaner sketch. So let's go and show you a different example and see how you could actually use cross-section sketches in Fusion. This is a oil cover. Let's go and find that in the browser as well. And we're going to go and open this file up and see what we have in here. This oil cover is also a triangular mesh, just like most meshes you work with. We're going to go and look at how many triangles we have in this mesh also, see what we're working with, and whether we can do that mesh to B-rep conversion or whether that wouldn't even work. Let's go and get our properties, and it looks like this one's 29,000 faces. So if I wanted to, I could convert this directly to a B-rep. I could make my sketches, but again, those sketches are probably going to be ugly unless I'm redrawing them from scratch myself, using projected points and placing those circles like I did earlier. The other option that's built into Fusion is actually creating cross-section sketches from the mesh directly. So to get there, we're going to go under Create, and we're going to say we want to create a mesh section sketch. We're going to pick the mesh body. It picks some sort of plane at random, mostly based on where you selected it, but we're going to then go and select a new plane. Now, I already added construction planes to this file, right? I was trying to save us some time on this live stream, and it was good that I did because for 5 minutes or so, I talked without a microphone. But in this case, we're gonna go and grab, let's say, the back surface as our plane. And what you could see is in orange, a cross-section sketch. Let's go and hit the OK button. Let's hide the mesh itself and see the sketch. And we're gonna go and edit the sketch and take a look at what's inside. What you're not going to see at this point is you're not going to see the ability to actually select this and extrude it. This orange kind of version of a sketch is not really a full sketch. You can't select this and extrude it or revolve it or anything else. This is kind of like a halfway to the sketch you want. But we have tools in place that are going to help you get to what you want. So under Modify in the Sketch toolbar, or the Sketch tab, nope, that wrong place. Under Create, under the Sketch tab, you're going to find a tool called Fit Curves to Mesh Section. That's what you're going to need to use to finish this into a real sketch. I select that tool and I get a bunch of pop-ups. We're going to say, what are we going to fit this to? Like, what's the shape that I think this should be? I'm going to choose a circle for now. And then it asks me to select the section. And I'll go and select this inner circle. And it already created a proper circle. And this is a proper single vector-based circle. Not a bunch of polylines, nothing like that. This is a proper circle like you modeled it, but it's automatically aligned to that orange mesh section. Now I'm going to go and hit OK, and you could see that this is highlighting in bold the outer contour, the profile as we call it in Fusion. I also get the peach fill on the inside, and those to me tell me that this is a proper sketch, and if I wanted to just take this and extrude it, I could go and do that using proper solid modeling techniques. I could also do a surface extrude or anything else that I want to do. I could go and do that without any problem. But maybe I want to go and do something else. And this is, by the way, oh, I have to show my solid. I had the triangular mesh. This would be a solid cylinder based on that. Let's go and cancel it. Let's go back into our sketch and start to add more information here. Maybe, for example, I want to keep going. So let's go and do another Fit Curves to Mesh section. If I choose this outer shape, you'll see that it's trying to fit a circle to it, which is not a realistic shape. So this isn't doing a good job, right? That wouldn't be a right shape for that. But I could choose, like, I want a closed spline, choose the shape, and now it's looking better. Maybe I'm going to go and use circle for this, and for this one, and for this one, and this one, and this one. And those are looking really good. Or maybe I want to take that outer shape and I don't want to just use this as a spline, and maybe I want to recreate it. Well, even then I could delete this, and keep in mind I could still use my other sketch tool, like offset. I could choose an offset, approximately that amount, start to zoom in a little bit and see what this value should be. And maybe based on this, it should be 0.12 and leave that there. And I can add my parametrics too. So I could have dimensions excuse me, between the different sketches and different other entities. And when I'm ready, I could go and take this and I could use my solid modeling techniques like I showed you earlier, and I can extrude this. Let's go and show our bodies again. I could extrude this, start to add draft to it, or start to use other reference geometry of my mesh to figure out what I should do to end up with a solid model. But remember that very first method that I told you about if you don't have to reverse engineer it, don't reverse engineer it. You might not need to make a full 3D model of in BREP form of this oil cover. And if you don't need that, don't make it. If all you care about is the position of the holes, then only reverse engineer the holes. So as an example, when we talked earlier on this motorcycle about the very front end, maybe you only care about the hole position of this particular piece, right? You could see that these line up. This hole and this one over here, they all are supposed to line up. So maybe all I care about is that. So if we go back to our oil cover, maybe I don't want to reverse engineer anything related to that. All I care about are those holes. I've just reverse engineered those hole positions. Now I have that in a sketch. I could actually go and create a totally new sketch of a totally different part that I want to create that maybe is just going to use those holes. So now I could go and take just this shape and solid model that. Let's go and show our solid modeling toolbar here. This is way too thick, so maybe I'm going to go and make this 1/8 of an inch. And now I have a pretty boring plate, but I have the hole positions exactly where they should be. And if all I care about is how they line up with the rest of the oil cover, well, guess what? I've done exactly that right here. I don't need to reverse engineer the whole oil cover. I just need to reverse engineer the position of those holes. And I've done just that. So that was technique number 4. For technique number 5, we're going to go, I think, just a few minutes over our 1-hour mark. I hope that's okay with you. For technique number 5, we're going to show you how to use T-splines to pull your geometry. And this is going to work really well for your organic shapes, not so much for your geometric shapes. Let's go back to our Trail 450, and we're going to go and find an organic shape here. And I think the seat is probably a great example. So we're going to go and open up this seat. We're going to go find our file here and hit open. And you're going to see I have a pretty organic shape. I mean, it's not the most organic of shapes, but I have a pretty organic shape here. Maybe I want to go and create a sketch for what we're going to work with. We're going to try this a couple of different ways. So let's go and create a sketch. We'll zoom out and maybe use this plane here. We'll zoom in a little bit, and maybe I'm going to go and use, maybe it'll be a simple arc for us today. So I'm going to choose an arc from here to here, and I'm going to try my best to make this kind of match. But you'll notice I'm not even very good at this, and that's okay too. Right? It doesn't have to be perfect. It's just trying to get you close enough. So that's a good sketch. And keep in mind, I could combine my different methods together. So I could actually use a mesh section sketch to create my sketch that I'm going to then use for this 5th technique. But either way, I have a sketch. I'm going to go into my T-spline or form, or also called sculpt environment. We sometimes have too many names for the same thing. But we're going to go into that sculpt environment, and we're going to go and create a extrude. I think that'll work great. We're going to go and extrude this sketch, and we're going to extrude it this direction just a little bit, and we're going to hit the OK button. I'm going to go and grab this edge, and we're going to go and add more geometry. Using my manipulators, I could go and drag this wherever I want, but I want to create new geometry, so I'm going to hold Alt and then drag this manipulator, and I'm going to start to create new geometry just like this. Cool. I'm going to go and take this region right over there, and we're going to go and move that in a little bit for this purpose. We're going to do the same thing over here. We're going to go and move that in just a little bit as well. And generally speaking, I have my surface, and it's starting to match my shape. We're going to go and take this whole thing, and we're going to go and add some symmetry as well. So we're going to duplicate it across my center line, just like that. And now I have a rough shape, but this is really, really rough. This really doesn't match. This doesn't match my seat at all. But I can use modify and pull to be able to make this match much better. So let me show you how this works. We choose a target, I'm going to select it myself. That's going to be the mesh that's in the background. And then I'm going to select vertices of my T-spline. And what it's doing here is it's actually moving that point to magnetically attract to the closest available area on the mesh, the target. And so it's moving it until it matches, which is pretty cool. And so right off the bat, this area in the middle matches much better. But I don't want to do that over and over and over again by selecting lots of points. So what I'm going to do is I'm going to deselect those 5. We're going to zoom out, and I'm going to select all of them at once. And just like that, this is the sound effect I think it would make if Fusion made sound effects. It would go, and it would shrink wrap your T-spline right onto your seat. And so now I have a really close fit of what this shape is. And I could look at that, and if I want to clean it up, I could still clean it up. So if I want to straighten these lines up, like I have something funny going on over here in the front. And so if I want to clean this up, I could go and take a region like this and say, let's go and rotate this just a little bit. Maybe take this one, rotate that one a little bit. Maybe move it over till I get this how I want it. Maybe take this one and move that over as well. You get to choose what you want to do here to manipulate your geometry. But overall, you're going to be able to manipulate it. And if your manipulations actually made this match worse than before, well, just go back and do that pull command again. So this time we're going to go and select this region right here, select the target again, and now it goes and fixes everything so it matches. Again, this is great for organic surfaces. And the key is that when you're done and you hit that finish form button, what we're going to do is we're going to convert that T-spline into a B-rep, just like we did earlier when we took our quad mesh and turned that into a T-spline, turned that into a B-rep. We're going to be able to do that too. The difference is that because I'm working, at least at the moment, with just a T-spline surface, this isn't going to be a solid yet. This is just a surface, but I do have a nice clean surface to work with. Now, even though this isn't a solid, there are a number of reasons you might want to do this. So just as an example, if it turns out, let's actually show my mesh again. If it turns out I want to design some sort of handle for this seat, and I know that, a handle for the seat might be made of upholstery, it's not really a hard part. Maybe I do want a hard part that's going to wrap around the seat. Who knows what I want to work on? And so the cool thing is that you get this surface that's a nice clean surface, that's a B-rep surface. And I could take that surface and I could use my traditional modeling techniques, like say I want to thicken that surface, give it whatever thickness I want. In this case, maybe let's say 1/2 inch. Oh, too many decimal places. 1/2 inch. Then I could go and using my normal traditional modeling techniques, I can come in here and draw a rectangle. Like I want maybe this handle to be in this location right here. Maybe I pick the dimension. I want this to be 1 inch wide. And I could position this exactly to maybe the origin or something else. It doesn't really matter. And I could take this sketch just like that, and I can extrude that through my solid. Let's go and do that. We're going to go and say I want this to go all the way through, but instead of cutting all the way through, maybe I want an intersect. And now I have this perfect fit. So even though I started with a surface, I was able to thicken it, trim that however I wanted to, and then now I can go and add more details that maybe I care about. So maybe in this case, it's going to be, filleting this thing like crazy. Maybe we'll add 1/4 inch. Something like that. Maybe I extend this, maybe I don't. You guys get the idea here. I'm able to take a T-spline surface, make it match a mesh very quickly and easily, and then be able to use traditional modeling techniques in the B-rep or parametric solid modeling or surface modeling environment to be able to make whatever I want. And this is going to be a perfect fit. I was talking to a customer just the other day, and they actually 3D scan the roofs of vehicles, and they make custom roof racks to fit all the vehicles. This would be an absolute perfect way to make sure that your design, if you're making roof racks, is going to fit that roof. So you 3D scan the roof of a Subaru WRX. Love those cars. And then you could actually go and make a T-spline, make that match that roof, and then use the thicken command to be able to design your roof rails. Right? So this is a great technique for organic surfaces, especially big, kind of smooth ones, and also organic shapes as well. So far, let's actually go back to our list. I want to make sure that we covered everything. We covered using the mesh data as is. And part of that, again, is not reverse engineering things you don't need to reverse engineer because it's a waste of your time. We talked about mesh to B-rep and the limitations that come with that as well. We talked about tri-meshes to quad meshes to T-splines to B-reps. We also talked about pulling sketch cross-sections and turning that into solid models or not. Maybe just using those cross-section sketches to line up with other things, whatever you prefer. And then lastly, we talked about T-splines and how you could create a T-spline really quickly and use the pull command to make that match. So overall, we showed you quite a few different techniques, and I hope that you've learned from it. I apologize again about the no microphone for about 5 minutes. That did not sound fun. It actually didn't sound like anything at all, so that was definitely no fun for both you and for me. But either way, I hope you were able to learn quite a bit from this tutorial on 5 ways to reverse engineer your meshes in Fusion 360. And if you have any questions, please put them in the comments area. If you liked this video, please like the video. There's a like button. And any questions that Brad might not be able to answer on his own, I will make sure to answer after this live stream. So thank you so much for your time and for bearing with our technical issue. I hope you have a great day. And don't forget, with Fusion 360, you can make anything.